Welcome and thank you for joining us today for this SPE Tech Talk with Solugen. I'm Joe Sinnott, your host for this broadcast, which will focus on the oil field's relentless battle against microbial activity that causes significant challenges like microbially-influenced corrosion and sourcing or souring. Despite the widespread use of biocides to combat these problems, maintaining control over microbial populations remains a complex task. We're joined today by Solugen to delve into the critical factors that lead to biocide inefficacy, including interactions with other chemicals and environmental elements that result in partial or total deactivation. We'll also explore the implications of this on operational costs, as well as emerging strategies to enhance biocide performance and boost antimicrobial efficacy without increasing toxicity. And if you would like to boost the efficacy of today's live broadcast, the best way to do so is by sharing your questions and feedback about today's topic in the comments section on either LinkedIn or Energy Stream. And our expert from Solugen will answer as many of your questions as possible later in the show. Two other great ways to interact with today's show are: one, to let us know where you are watching from, and two, to answer today's audience poll question, which is: which primary biocide or biocides does your company use? A, glutaraldehyde and glutquat blends; B, THPS, THPC; C, DBNPA or Bronopol; D, oxidizers; or E, other products. Let us know your answers in the comment section, and we'll take a look at the results later in the show with our guest. And speaking of our guest, let's go ahead and introduce Matheus Paschoalino, who is based in Houston, Texas. Matheus is Senior Business Development Manager and SME for Microbial Control with Solugen. In his current role, Matheus is responsible for Solugen's biocide potentiation project using novel bio-based and carbon-negative chemicals. He holds a PhD in chemistry, and his 20 years of experience includes R&D and advanced technical support in different subjects, including corrosion and microbial control in various markets. Matheus has 8 patents, 1 book chapter, more than 10 articles in scientific journals, and more than 4 dozen papers and presentations in various conferences. But as impressive as all of that is, the most important thing is that he is here with all of you today on SPE Tech Talk. So with that, Matheus, welcome here to SPE Tech Talk.
Thank you, Joe. Thank you for the intro, and good morning to you all. It is a pleasure to be here.
All right. Well, it is a pleasure to have you here. And if you would, could you kick off today's conversation by giving our audience an overview of the challenges involved with microbial control in the oil field?
Okay, yeah, microbial control is a very complex area. I would say is one of the most complex area in the oil field, especially because there are many variables and factors interconnected that cause these challenges. So I think we can start by the technical side. One really challenging part is the monitoring. So there are different techniques to monitor microbial issues. The most common ones are the culture media, so very known as the bug bottles. In general microbial control, we really try to measure sulfate reducing bacteria, the SRBs, and we have some new methods as well. So, but the main challenge here is there is no ideal method for our condition. So you need to know your field condition, your problem very well to decide what is the best method. So just to give an example, if you use a SRB bug bottle to monitor your producing water and you start to see no turning bottles, for example, but you experience H2S, so biogenic H2S, maybe there's a problem with your for culture media. Maybe you are not using your right culture media. So these media are very selective, and many times you are selecting the organisms that are not related to your problem. So other typical method is ATP. ATP you measure through indirect method, so you measuring the ATP molecules. There's a transport molecule of energy in all the cells, and you also can be influenced by stress of the cell. So you have peaks of ATP depending on the time. So it's very difficult to correlate to the bug bottles or to the culture media. So I would say using more than one method is a very good way to overcome these challenges. And DNA methods are really good ones, but still new for the field. We have some qPCR arrive in a portable way that's it will help, but it's still not the most cost competitive, I would say. So beyond the monitoring, uh, I see the industry is still thinking much more on their remediation part than the prevention. So this can be a issue, especially the cost at the end of the run. So it would be much better, much cheaper work on the prevention. So dosing adequately, then inspect the HOS, the issues. Occupational safety is always a challenge. Biocides are toxic chemicals. So we know everybody would like to have a green biocide or a non-toxic biocide, but this is very utopic. So they need to kill something, and we don't want they kill us. So toxicity, ecotoxicity is always a challenge. We need to think well how to overcome this toxicity problem, how to handle this adequately. And what we a lot of people underestimate in the field is the biocide deactivation part. So the like from the 300, 400 ppm you dose of your biocide is rarely where you a situation where you measure the remaining residual. For example, if you dose at the beginning of a pipeline, is really rare you check the active at the end of the pipeline. So these biocides can be really easy deactivated depending on the condition of your field. So this is one of the three, four challenges I can see of the time today.
Okay, so on that last challenge that you mentioned, the biocide deactivation, what are some common scenarios when that pops up, when that challenge is something that companies then have to deal with?
Yeah, I can mention some example that we have a slide for that. Yeah, biocides can interact in with the environment surrounding. So especially other chemicals is very common, like your corrosion inhibitors, scavengers, polymers. So one very common example is scavengers, so oxygen scavengers that very used in water fluiding, for example. They typically deactivate most of the biocides. And in general, you need to have a strategy or stop dosing during the biocide beds, things like that. So it's very common. Some corrosion inhibitors like amines can deactivate some biocides, like glutaldehyde, for example. THPS is one of the cases we'd like to emphasize today. THPS can be used, for example, as iron control, so it's excellent iron chelator. And when you are dosing THPS as a biocide, so when you want a biocide activity from THPS and you have a pipeline or a tank full of biofilm and iron sulfide, for sure this THPS will act first as an iron chelator. And if there is any uh, remaining THPS, it will act as a biocide. So the water chemistry also can play a role, especially quartz. Quartz can struggle in extremely like high hardness water or high TDS. They can interact. They can interact also with surface. So there are some studies showing how quartz can interact with the rocks in the formation, for example. Metals in general, anionic polymers are very common to interact with cationic like THPS, so we can deactivate. And the common thing of temperature and pH. So there is ideal pH range for the biocide to work, and also there are some limitations on temperature for many biocides. On the right, I just put some of the situations what can happen if you have this deactivation. That's very common. Further thing is lack of control. So in general, if you use our biocide as just a checkbox, and you know you have to dose, but you are not sure about the dosage. And if you are dosing less than the minimum inhibitory concentration or less than the situation to overcome this deactivations part, you probably you experience the deleterious effects like souring, H2S generation, the microbial influence corrosion that is very serious, and biofilm that can cause many problems. So biofilm can protect the internal cells from the biocide, can cause clogging of filters as well. And to compensate this, when you are already aware you are, for example, in a major field, or you know the problems you have, and you need to overdose, especially if you are operating on a remediation way, you try to compensate for this deactivation. So you dose to already counting with the deactivation, and you have some residue, but this increase your costs a lot. So they may increase a lot your cost. And there are some other aspects like handling. You probably, if you overdose, you have excess of handling of this toxic chemical, and also cost of logistics in in other areas.
Well, I think we've spent about 10 minutes laying out the challenges and the headaches
Mhm.
associated with this. So I'm anxious, and I think our audience is probably anxious to talk about, all right, well, what are some things you can do about this? But before that, and speaking of our audience, I want to remind everybody out there that, we're here to get your questions answered. So please take advantage of this live broadcast. Don't worry about bugging Matheus here, right? I mean, a lot of people think
Mhm.
biocide, they think about bug management, right? So your job today is to bug our expert, ask your questions, share your comments, share your thoughts about today's topic. And again, Matheus will get to as many of your questions and comments as possible later in the show. But for now, as I said, let's kind of flip things in the other direction. So you laid out all of the challenge, you laid out some of the the issues or the variables that could lead to biocide deactivation. What about biocide improvers, Matheus? What about things that, again, are going to, help kind of move things in the positive direction? And I guess along those lines, what are some of the additional challenges that come with the adaptation, or the adoption, I should say, of those improvers?
Sure. Yeah, biocide improvement. So it's not a new area. If you, especially if you go to the literature, many chemistries were tried to improve biocides in some way, like or co-feeding or co-formulating, like co-blending. In this slide, like, we can see some of the ideal properties, I would say, for biocide improvers in the oil field, especially if you go to the current situation, going to the green side of the things. And here I can give some examples depending on the property here. So cost performance for sure will be what will be a a key point of decision for the implementation. So it doesn't make sense you take a new product to reduce your dosage from 300 to 150 ppm, for example, for the biocide, and you need to add 1000 or 2000 ppm of this improver. So, and this the literature shows in some points. So, some improvers like chelators in the literature, they need to be dosed 3 to 4 times what the typical biocide does. So this doesn't make a lot of sense for the field. Or when they are more efficiency on the dosage rate range, they may be very cost, like the sticker price of these products still can be very costly. So this also is a challenge to be adapted. So I think EDTA, I mentioned EDTA could be, when I mentioned the iron part, they can calculate the iron, but also calculate other cations like calcium. So you don't want your improver being deactivated by the TDS or by the environment. You want its activity over what deactivate your biocide. So toxicity also very important, especially if you are offshore. Like, for example, you need to dispose this into the sea. Uh, the the profile of biodegradability needs to be good enough or compatible enough to be used. So you don't want to dose an improver that is even more toxic in general than your biocide. And compatibility, as we mentioned here, compatibility with oxidizers. Oxidizers are very common biocides in the field. So it's very common strategy. You start with oxidizer, independent if you are in fracking or you are offshore using an electrochlorinator, for example. And after when you go to injection well or go to the blender, you use a non-oxidizer biocide. So it needs to be compatible with oxidizers because it's very common in the oil field, and also other chemistry like I mentioned before. Not affected by different TDS, low foaming. So I mentioned foaming here because many surfactants were used in the past as try to be a biocide improver,
Mhm.
and they have a lot of limitations on the doses, so you never can go very high because of the foaming property. So you don't want your separator or your pumping cavitating because of the foaming. Don't interfere in the oil emulsification, so you want to continue your great separation of the oil in the water. So you want the opposite effect if possible. And the last point I bring here is the carbon footprint. So I think nowadays we are seeing this pushing on the green direction. So it doesn't make sense you replace partially your biocide by a product that the production process is nasty. So full of byproducts, for example. So ideally, if you can replace by a chemistry with a good carbon footprint profile and reaching matching all these other parameters would be the ideal road. I would mention here other products that were used in the past, like enzymes. I think the main issue to be implemented was the cost performance. The cost on that moment was not ideal.
Mhm.
There are regulatory issues, so especially in the US and Canada and Europe, it's not easy to it's not easy yet. We may be in a gray zone sometimes.
Sure.
But this is the topics I could bring today. Yeah.
Okay. So I guess, obviously hearing you talk about all the green check marks there on your last slide, right? The things that you want to take
Mhm.
advantage of. Let's talk about the actual implementation in the field and field trials. Again, our audience here typically on Tech Talk is, they want to cut to the chase and say, hey, does it work? So when it comes especially to novel bio-based biocide improvers, Matheus, can you talk about field trials? Can you talk about the results that you've actually seen, out there being implemented?
Yes. Yeah, we'll bring some data in the slide, but we brought two field trials today. It's basically just to show two field trials that the after field trial the operator decide to implement the technology. Just to show you in very different ways. So one was a continuous dosage of the biocide. It was a quat DDEC. The other was a offshore tank in Brazil where they used to use just DHPS. Those are the in batch in slug dosage. And different ways of monitoring. One monitoring on bug bottles, the other monitoring just H2S and ATP. So just to show you how robust this type of strategy can be. So this is a chemistry like produced by a unique production process and can match all the properties we discussed in the last slide. And I think you can put the slide. I will start with the first trial on the graph on the left, field trial one. So this is the deck, a quat potentiation. This is a big site in the US where they used to have these production water recycling facilities. So they need to treat the water and to reuse in fracking. And they were experiencing H2S in the tanks and the systems. Besides a high dose of biocide, they used to use beyond the DDEC, they used to use 120 ppm of a diluted DDEC. They used to use 100 ppm of THPS, and they used to use a glutquat in the blender. In here, after doing some lab trials and do the field trial, we first compare. A good way to do these trials is do a overlay. So you already have your 120 ppm. Let's try put the 120 ppm of this new bio-based product and see what happens if you see any improvement of performance. After you see the improvement performance, you can start dial back your chemistry and optimize dosage. So at the end, this customer, they could reduce the DDEC dosage to the half. They could completely remove the HPS and they continue with the glutequat. And here you can see the bug bottles monitoring in the field. So they used to have 10 to the 6, like 6 turning bottles for SRBs, 4 turning bottles in average for APBs. And here's the average of the bottles after they implemented the treatment. So in general, very much more robust, around 1, 2 turning bottles most part of the time. Was a huge reduction in biocide volume for this customer, and they start to expand to other regions that they have oil fields. And also, I can comment about the H2S on the flowback water on the fracking part. So when they implemented this, they continuous monitoring the typical 90 days flowback water, they stopped to see H2S in these 90 days when comparing to the other wells that didn't use this technology. So this was also a huge benefit for them. The second trial on the right is a trial we did in a slope tank offshore in Brazil. So for those who know, offshore is a really challenging environment, especially in terms of logistics. So you don't want to deal with a lot of volume. You cannot keep a giant inventory. You need to bring products by boat. And these are tank, really large tanks, and really tough to have a good diffusion of the product. So you only can dose practically at the corner of the tank and hope for any progress or any diffusion. And even this tough situation, so even like thick layers of oil and biofilm, we could demonstrate the potential of this technology. If you see, the gray bars are typical average levels in the months before, and they used to dose from 150 to 500 ppm of the HPS. We decided to start with the lowest dosage, like 150 ppm of the HPS, and we complemented with our technology, like plus 100 ppm is typical cleaning step. We begin with this and doing batch doses. So 3 times a week. In the first week, we already reduced the beginning of 25 ppm H2S to less than 10 ppm. In ATP, you can see the line is ATP, very correlated to the H2S. So just proving we are not scavenging H2S, we are really acting on the root cause, that's biofilm. And you can see on the following week, we could reduce to twice a week and reduce the dosage. In the final week, we reduce to the half the THPS dosage in our chemistry. And also we just once a week we could keep the control like less than 1 ppm H2S. That's the limit of the method they were using. So you can see also the visual aspect of the sample, how it was before, like this layer full of iron sulfide and some free material, and how it got after, so much more clean. So we really interact with this environment that deactivate the HPS. It was about 50% reduction in volume. Both cases they were implemented in the field, and the treatment is still there.
Got it. All right. So thank you for sharing that again. As I said, appeasing our audience's undoubted curiosity about what are the results that you've seen. And again, speaking of our audience, probably a good time to revisit the poll question that we asked everybody earlier when we said, hey, what primary biocide or biocides does your company use? Now, it seems like, gluquat, THPS seem to be widely used in, applications across oil and gas. Don't know that we saw anything different in our poll today. What do you typically see? Maybe a quick response from you, Matheus, on what do you typically see when it comes to the biocides, the primary biocides that folks are using out there as we sit here today in 2024?
Yeah, as I have a lot of experience beyond the US. So in the US, we are seeing still the glutequats. I think we got very different ratios that you can imagine, from glutequats, higher glute, low quat, or higher quat, low glute. Combination of quats with glutaraldehyde probably is still the major product we see, especially in the US, especially in fracking. When you go international and you go offshore, THPS is the main active for sure. So especially in Latin America, even onshore in Latin America, the HPS is still a big active in these many points play a role here, like cost, importation cost, and things like that. But is I would say the HPS more on the production side and glutequats on the fracking side, yeah,
Okay,
and
great.
and beyond oxidizer for sure, yeah.
Great. All right. Well, thank you for your insights there. Again, I want to keep turning our attention to our audience. I know we have one question that came in from Salima on LinkedIn, and she wants to know, all right, can green chemistry be used to develop more sustainable and effective biocides? So what do you say to that, Matheus?
I would say yes. So if you go to the production process today, we always forget about the carbon footprint of the chemical we use in the field. So, for example, if you replace 1 ton of DHPS, for example, by these new bio-based chemistries, especially the high efficient chemistries, high efficient process, you can create generate a carbon credit, for example, of 2 3 tons of CO2, and this is a thing that people are not taking account yet. So you can improve the process, so you can use new technologies like uh, uh, the ones we use in Houston, Texas, that is a chemoenzymatic process. So enzymes do chemistry very well. You can do the reaction you want and have like a 95% efficiency in the process. So you can consume more CO2 if you part from a raw material that is bio-based. We use nowadays corn syrup, for example, to produce this new material, and you can have this carbon advantage product at the end.
Oh, very neat. All right. I guess now you have me curious. So, any other
Mhm.
insights or curiosities on the actual derivation of these products? Anything else that might be interesting for our audience to kind of take away that they might not have known about how these products come to be?
Sure, I can give more details. So basically, we start with corn syrup, but basically it's dextrose. So it's a sugar, and we use a unique technology that's chemienzymatic. So the first step, we pass through our bubble column using specific enzymes that we have a team of strain engineering. For example, we generated these enzymes in-house. So we use the exact enzyme to generate the new Cas number intermediates and very efficient reaction. These new intermediates we pass through a more traditional metal catalysis. So we oxidize these sugars to what we call polyhydroxy carboxylic acids in different mixtures of these acids that we may tailor depending of the application. So, for example, we have a better mixture of these acids for work with oxidizers. We have another mixture to work with no oxidizers for sure. But this is basically the way we do it. As we use corn syrup, and the process is really efficient. Over 5%, we can consume more CO2 in the process than the emission. So we can claim our product is carbon negative at the end. So
Nice, very nice. Let's see here. No shortage of questions to follow up on, but there is a shortage of time here today. So let me turn it back
Mhm.
to you. Anything else here as we kind of come to the end of the show? Anything else that you want to share? Anything else that you want our audience to walk away from today's conversation with, Mateus?
I would say to the audience to take a look on this new technology. I think, especially the end users may not be aware that this is already commercially available, and so please ask your service company or reach out to us directly, and we can talk more.
All right. Well, that being said, if people do want to talk more, if people do want to reach out with their questions and curiosities, what is the best way for them to go ahead and do that?
Yeah, you can go to our LinkedIn. So I think the quickest way to reach out to me, and my team will be on the ATCE next week. So we have a booth there, booth 1645. So please come by and ask many questions as you want for to the team.
All right. Well, thank you very much, audience. Again, there you go. You have the invitation to reach out in person via LinkedIn, however you want. So our goal here on SPE Tech Talk is to remove those barriers. And again, if you're in the operational world, to help hopefully remove some of those costs and deal with some of those challenges that you might face. In particular, today, challenges and opportunities around the performance of biocides. So with that, Matheus, thank you very much for all your insights. Thank you to our audience for your questions and your participation. And of course, a big thanks to Solugen for helping to make today's broadcast possible. If you would like to watch a replay of today's broadcast, you can do so by heading over to the SPE Energy stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
Don't miss a moment of any of the great SPE LinkedIn Live events. From the event page, click Attend and add to calendar for notification reminders when an SPE LinkedIn Live event is ready to begin. SPE Lives, Tech Talks, Get to Know series, and more. Remember, click Attend on LinkedIn.
In a rapidly evolving energy industry, you need to stay ahead of the curve with relevant content available when and where it's convenient for you. You need the upgraded SPE Energy Stream, the global platform for high-quality content with the energy industry. Fuel your energy career with Energy Stream's sleek new look and easy access to top-quality technical solutions, insights and innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event highlights, this exciting, easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders. Then save the videos that interest you and watch them at your convenience. Be at the forefront of energy knowledge and explore the newly updated SPE Energy Stream now.